The first factoring method that we are going to learn is factoring using greatest common monomial factor. So the greatest common factor of two or more whole numbers is the largest whole number that divides evenly into each of the number. So I have here three examples. First, let's find the GCF of 42 and 60. So the way we are going to solve the GCF here is to write the prime factorization of each number. For 42, I'm going to use the ladder method, wherein we are going to find the smallest prime number that can divide 42. So 2 divides 42. So 42 divided by 2 is 21. Then find smallest prime number that can divide 21 again. 2 will not work, but 3 will work. So 21 divided by 3 is 7. Now, you know that you are done if after dividing, you are going to get a prime number. Since 7 is a prime number, we are done finding the prime factorization of 42. So 42 is equal to 2 times 3 times 7. Next, let's get the prime factorization of 60. Again, find the smallest prime number that can divide 60. 2 will work. So 60 divided by 2 is 30. Again, find the smallest prime number that can divide 30. 2 will not work. 3 will work. So 30 divided by 3 is 10. Smallest prime number that can divide 10 will be 2. 10 divided by 2 is 5. Since 5 is a prime number, we are done. So the prime factorization of 60 is 2 times 2 times 3 times 5. So 2 times 2 times 3 times 5. What prime factors do have the same numbers in common? We have 2 and 3. So 2 and 3, just get a product of 2 and 3 and we're going to get 6. So 6 is a GCF of 42 and 60. So 6 is the largest number that can go into 42 and 60. Next example. Let's find the GCF of 15 and 45. So we are going to get the prime factorization of 15. Smallest prime number that can divide 15 is 3. We'll get here 5. Since 5 is a prime number, we're done. Prime factorization of 15 is 3 times 5. Next, 45. 3 divides 45, which is 15. 3 divides 15, we'll get 5. So prime factorization will be 3 times 3 times 5. What prime factors do the numbers have in common? We have 3 and 5. Multiply these two numbers and it will give us the GCF. So 15 is the largest number that go into 15 and 45. So the GCF is 15. Next example. So I have 40a squared and b. So let's try to find the prime factorization of 40 first. So divide this by 2, we'll get 20. Divide by 2 again, we'll get 10. Divide by 2, we'll get 5. So we have 2 times 2 times 2 times 5. Now your a squared is a times a and then times b. Okay, next 48. Divide this by 2, we'll get 24. Divide by 2, we'll get 12. Divide by 2, we'll get 6. Divide by 2, we'll get 3. So we have 2 times 2 times 2 times 2, and then times 3, and I have A and then B4. The factors that are common to both expression are 2, 2, I have another 2 here, I have A and then B. So if we get the product of all of these factors, we'll get 2 times 2 times 2 times A times B. We'll have 2 times 2 times 2 is 8AB. So 8AB will be the GCF of 40A squared B and 48AB4. There's another way on how to get the GCF of two numbers. This is very familiar to you guys because it's very similar to the ladder method. So I'll just line up the two numbers, let's say 42 and 60. So let's use our ladder method and show that we are going to get the same GCF. So I'll write the upside down division. Think of prime number that can divide both 42 and 60. 2 will work. So 42 divided by 2 is 21. 60 divided by 2 is 30. So again, find prime number that can divide both 21 and 30. 3 will work. So I'll have here 21 divided by 3 is 7. 30 divided by 3 is 10. Now here I have 7 and 10. Now there's no prime number that can both divide 7 and 10. So these two numbers here will give the GCF of 42 and 60. Just take the product of 2 and 3, which is 6, and that's the GCF of 42 and 60. Okay, let's use the same method, getting the GCF of 15 and 45. Again, think of the smallest prime number that can divide 15 and 45. So 3 will work. I have here 5. So 45 divided by 3 will give us 15. Smallest prime number that can divide 5 and 15 will be 5. 5 divided by 5 is 1. 15 divided by 5 is 3. We will not be able to find a prime number that can divide both 1 and 3. So the GCF is the product of 3 and 5, which is 15. The same answer that we got earlier. Alright, next, 40 and 48. For the meantime, we'll just deal with the two numbers 40 and 48. So think of the smallest prime number that can divide 40 and 48. 2 will work. So 40 divided by 2 is 20. 48 divided by 2 is 24. Think of smallest prime number that can divide both 20 and 24. So 2 will work again. I will have here 10, 12. Next, think of a prime number that can divide 10 and 12. 2. So 10 divided by 2 is 5. 12 divided by 2 is 6. Now here, we don't have any prime number that can divide both 5 and 6. So I will have 2 times 2 times 2, which is 8. Now since we have variables a squared b and ab4, to get the greatest common factor of these sets of variables, we just have to compare a squared and a. We are going to get the expression that has the smallest exponent. So in this case, it's a raised to 1. This one is a raised to 2. We are going to get a raised to 1. Now between b and b4, we are going to get the expression or the variable that has the smallest exponent, in this case b1. So this will be the GCF of 40a squared b and 48ab4, which is the same GCF that we got earlier.